Hey everyone, in this video we want to solve problem 120 triangle using DFS and caching. In this problem we are given a triangle of integers like the one that you can see in this example, and each cell is an integer with a value, and the task is to wanna start from the top of the triangle and eventually reach to any cell in the bottom of the triangle and find the path that has the minimum cost. And the cost of the path is defined by some of the values that we see through our traverse from the top to the bottom. And the other rule is that at each step, we can either move, if we are at some row and index I, we can either move to index I or I plus 1. Or if you consider it in a triangle, so in a cell, you can either go to the left or to the right cell in the next row. So one other way is to consider, instead of seeing a triangle as it is depicted in this example, you can consider it as a perpendicular triangle like this. So at each step you can either move down or move down right, and you can be sure that always I plus 1 exists because the next row is exactly one cell larger. It has one more cell than your current row. So when it comes to finding a path with a minimum cost, the first thing that comes to mind is implementing a DFS function starting from a root and then going to the depths. But as we discussed in other videos, and as in these problems, in type of problems, the speed is always matters. So we can always speed up this process by storing the values of previously visited cells somewhere, so that we don't have to run the DFS again on some specific cell. So the depth of the cell could go to 200, and we know that for each cell we can store the value so that as soon as we visit it, we are sure that after this point we can store the minimum path for each cell. And eventually when we are running DFS from other cells and we visit this cell, so we don't have to visit these cells below of this specific cell because we have already cached that value. So for that, let's first of all find the n, or the length of the height of this triangle, which is n equal to the length of triangle. And then we have a DFS, and for at each step, how can we find what cell we are visiting? So row number and then I, as it is discussed here. So a row and an I, and let me pass that. Or first of all, we check the row. If row greater than or equal to n, so it is already passed beyond the bottom of the triangle, so we return 0. Otherwise, we run the DFS. So the value for the current node is the triangle of row and I, the value of the current node that you are visiting, plus there are two cases. We can either move left or right. So we run the DFS recursively for left children and right children, and then find the minimum of that, and then add it to the current cell that you're visiting, and as the result of the DFS for the current cell. So it would be equal to plus the minimum of the DFS on row and I, or row plus 1, the next row and I. So there are two cells, neighbor cells, I or I plus 1. So, and I plus 1. So these are two cells, the next cells on the next row. We are finding a minimum and then add it to the current cell that you're visiting, and this would be the result of that. So this is where the time-consuming version, but the thing is we can store the values somewhere in the cache, so that we don't have to repeat the DFS again and again on some specific cells, and if the cell is already calculated, so we just return it. One way is to define another cache exactly like triangle, so repeat everything like this and then store the values, initialize with some with some none or some value. But the way I like to do is to use dictionary as a cache. So I use a dictionary and I use the row and I as the keys to access this cache in order to check if the value is already previously calculated in previous iterations. So if row and I in cache.keys, that means we have it in the cache. Then simply just return the cache of row and I. Otherwise it is not calculated, so we should store that in the cache as well, equal to the car. So this is the DFS, and then run the DFS. We are visiting the first node that we are visiting is the first row, which is 0, and the first cell, which is again 0. I believe there's only one catch in this implementation, which is the edge cases are the number of n could be 1, but at the very first cell, we are visiting the first cell and then it doesn't have any next row. So let's just say if n equals 1 as an edge case, like this example here, we can simply just return the value inside that. So return triangle 0 and 0. Let's try that. And then try the other one. Okay, so I believe it should be fine. All right, so this was one way to implement this problem. There are other ways that you can always check in the discussion. Dynamic programming solutions are similar, so rather than running the DFS, so starting from the bottom and then eventually fill up this one, similar to what we discussed here, we are using a cache as a dictionary to store the values, the previously calculated values, but in a DP way. So you're making sure that you're iterating through the nodes and then visiting every node only once. It is quite the same in our case because we are not running the DFS, but the DP might be a little bit faster, but the total time complexity of these two solutions are similar. So that was everything for this video. Hope you enjoyed it.